Hello everyone and welcome to 19th lecture of this Global Navigation Satellite Systems and Applications. And in this discussion we are going to discuss about GNSS current trends and future. So what are current trends and what is coming in future that we will be bringing one by one. As you know that a lot of things are related with electronics here. And you know that development in electronic in recent years have been very fast, and therefore, whatever we are discussing today is going to change tomorrow definitely. Things are from very large GNSS receivers, they are becoming now very small. And as you can see that some of these receivers which are embedded in your mobile and smart mobiles or in independent GNSS receivers, they are getting smaller and smaller, and of course the signal quality is also improving, and therefore it is very difficult to predict basically that what is going to happen, what are the opportunities and other things. But let's see that what opportunities today we are having. And as mentioned here that it is very difficult for that describing the market is predicting its future, because things in this domain are changing at very rapid rate. Similarly, like in other electronics or like in mobile industry, so same is in a GNSS industry, because many countries, many big countries, powerful countries, or whoever requires their own navigation system, they are developing their own navigation systems and not exactly following what the first one, that is GPS, was developed by US, but they are doing their own innovations in not only in constellations but in receivers as well. And similarly India has also done, which we have discussed when we discuss IRNSS or NAVIC system, and the receivers are also initially in the beginning they were single frequency receivers. Now we are having dual frequency receivers, more powerful, more accurate and quick to get the positioning. So that if we look from this point of view, that market definitions usually start by counting the sales of the goods, but services loosely associated with the technology. So this trend basically continues, even in future it is going to continue. And nowadays a small chip which is having GPS or a GNSS receiver is costing say about $2, maybe 100 rupees or 150 rupees. And then there are more sophisticated for very accurate or scientific studies, or for maybe aerial navigations or for missile technology, which may cost or for nuclear hardened navigation, which may cost even $300,000. So the range of these receivers is very huge, very big, because there are different types of users from all walks of life, and accordingly the products are available. As you can see here in this table that the dimensions are changing, their signal noise ratio is changing, the capabilities are changing. As you can see here that with a very small one, which is just 40 millimeter by 15.4 millimeter, we are having something like other smaller one also, and which can go inside a smartphone very easily. So different types of GNSS receivers with different capabilities are available, and they as you can also see that some are just GNSS flexible antenna, and some are the active patch antenna, and some are having capabilities of receiving signals not only from GPS but Baidu, GLONASS and other constellations. So multi-constellation receivers are becoming much more popular nowadays. And this is what these multi-constellation receivers we are getting nowadays in our mobiles also. As you know that European Space Agency, which is ESA, which is focusing on the GNSS, so they call as a GSA, European GNSS Agency. They have been publishing some regularity about the GNSS market report on future trends for the GNSS market in Europe or world over. And what GSA has already reported that the key references for companies and organizations to build their market strategies is in relation to GNSS. And what underlying market model utilizes advanced forecasting techniques, which they apply to the comprehensive range of input data, assumptions and scenarios to forecast the size of GNSS market. It is growing like anything. And as you can see that and through our own experience we know that the most of the users of these GNSS receivers, they are using for navigation. So they are either location based services, which is 53.2, or for road navigation. But there are other users also, some are very small one. For example, time syncing to get a very accurate timing through the atomic clocks which are installed on the GNSS satellites or constellation, that number of the share in the market, or you can say, is just 0.1%. And of course, like railways, they have started using extensively, even Indian Railway, and in civil engineering survey or in some other surveys also it is being used. Similarly, in agriculture, it is being used 1.9% currently, but maybe in different countries, if we look the data, then it might be different, because only in those agriculture areas where farms are very big, they are employing these GNSS services, and then maritime. So the large users are of course the location based services, that is LBS, about 53%, and then road users are also there of 38%. So these are the main users of GNSS services, and also the current business opportunities are also in these two major domain, apart from some other domain as well, but they play a very small role. So in this, when we look this scenario of business opportunities, the assumptions are informed by expert opinions, and models results are cross-checked against the most recent market research reports from independent sources, and before being validated through an iterative consultation process with sector experts and stakeholders. Further, the first forecast is the actual global installed base of GNSS receivers or devices, which is 3.6 billion units is predicted to grow to 7 billion by 19 or 20 by this year. So you can see that it is going to be doubled in only very recently, in very recent years. Almost that means almost one GNSS receiver for every person on the planet. So almost everyone, some people are having their GNSS receivers inside their say mobile, but may not be knowing or may not be using that extensively. But most of these smart mobiles which are coming are all coming with some kind of GNSS receivers, and people or market experts they expect that this number will grow to maybe by 2020 2022 it may be again double. So this is going to grow at a very fast rate, because not only now people want some people want not only the GPS facilities or GPS receiver, but multi constellation receivers in their mobile to get a better accuracy, and that too very quickly. And as This growth of GNSS receivers is almost parallel to the growth of smartphones, which is also continuing to dominate. That is 3.08 billion was in 2014, and now this is out of which the applications bear 0.26 billion. And the primary region of global market growth will be in Asia Pacific region, where many users are there, and which is forecasted to grow by 11% per year, and that is 1.7 billion in 2014 to 4.2 billion devices in 2023. So, as we can see here, that as a smartphone market continues to grow, a similar way the GNSS market is also growing. Further, because new applications are being developed, new opportunities are also coming. Let me also give you that when we were discussing differential GNSS or RTK GNSS or this satellite based augmentation system, that means SBAS, through this course I have also learned that there are through net also you can get the differential signals quite easily and available freely. So, if the only requirement is that the same receiver should have a net connection as well, and if net connections is there, then through free servers which are providing the correction data. This we also discussed very briefly, but what I am trying to bring here that these servers which are providing freely correction data. So, one can configure their app to fetch the correction data from these servers, and the position, for example, one was getting say within 3 meters, 3 meter accuracy, that improves very significantly and may become even 50 centimeter or 0.5 meter or even 25 centimeter. So, from 3 meter you can reach to 0.25 meter accuracy just by engaging with those servers and getting or fetching the this correction data which might be available through these servers. Many of these servers are free, many of these servers are charging some money, or many of these servers are from the manufacturer side. So, suppose for example, if you buy a Trimble or US GPS or GNSS receiver, then you can directly get the differential signals from these companies' servers, maybe freely or maybe paying some money, or while purchasing these receivers you are paying that subscription charges for few years, and you get a very accurate position even using a single receiver and even without having your own base station or a stationary GNSS. So, because of such changes in the technology, the accuracy is improving, and therefore more applications will come in future which will exploit this available accuracy for different applications. So, the opportunities are really very large. As we have discussed that the maximum growth is happening in Asia Pacific, Middle East and Africa they will also grow at very fast rate, that is roughly about 19% per year, but currently it is not at that fast relative to our Asia Pacific region. And what here we see in this bar chart that smartphones growth relatively is very huge, and then there are some other electronics which are being used, and GNSS penetration in mobile phones is almost same as the growth of your mobile. This smartphones is there, and there are some other like tablets and portable computers and other things, they too are growing almost in the same pace. Whether we will achieve a plateau soon, I do not think so, because as the technology is developing, more applications will come. So, smartphones basically represents the vast majority of shipments, mainly due to their versatility and growing affordability. The best part in using these GNSS receivers in smartphones is that smartphones anyway it is multi-purpose because it is having camera and recording and voice recording and of course telephone and other things, net and but same time GNSS. So through these apps which are available or can be bought, can be installed on your smartphones, and they can use these multi-constellation data, and not only that but N-trip also, that is through network you get the correction data. So even a single smartphone can give you accuracy of few centimeters. So that is why this that growth is basically attached or linked directly with the smartphones, and because smartphones are becoming affordable and their versatility is also there, so that is why the growth is also there. Now other GNSS enabled devices accounted for more than 100 million units in 2013 that not inside the smartphone, maybe independent receivers. And there might be some other devices like tablets might be having GNSS receivers or Bluetooth based receivers or USB based receivers. Some people use these such GNSS receivers for their car navigation, because you know that road sector is using large GNSS receivers. So in cars also, so they might be using the USB one. So their shipment increased by 640% between 2010 to 2013. See the growth is a huge growth, and that major market are of course in Europe, North America and Asia also. And finally that wearable band market, because in the watches also the GNSS receivers are coming, because once the receiver itself becomes smaller, then it gets installed in many small devices. So the bands which people wear like a wristwatch, and which has also exploded in the first half of 2014, and which is a growth of 700%. So it's a huge growth in GNSS market. And high-end devices also which are using multi-constellation GNSS capabilities coupled with 3G or 4G and better connectivity, they too are sharing some market of GNSS. Location based LVS services rely on multiple locations technologies, often combined with additional smartphone sensors, and generally location data comes from like handset based technologies such as GNSS with computation performed mainly in the handset or on your mobile or a handheld device. Maybe network based technologies which we have just discussed, network based from caller ID based or radio frequency pattern matching, or this auto the computation performed mainly in the network. And moreover the advent of this hybrid technologies such as A assisted GNSS and OT duo with intelligence in both the handset and the network addresses user demand for access the location data in every environment. So people want that the location data should be available in almost every conditions, day and night not only, but in all weather conditions and inside buildings also. So therefore, because there are large buildings, large market and other places where people want the location itself. So that is also becoming possible. There are not simple GNSS receivers will work, but some other technologies have to be involved as just discussed, maybe hybrid technologies, and which will help users to get the location. So this market is again very much up, and in this perspective the GNSS with other location technologies like accelerometer, which is also in some of the mobiles, gyroscope which is also inbuilt in many mobiles, and compass. And these location technologies complement each other, provide reliable information not only about the location, but this is augmented data from the sensors in the handset. So the same device, that means maybe smartphone, can be used for multi-purpose. and a trend of integrating multiple GNSS constellation smartphone chipsets, and there are smartphones which are coming with this GPS, GLONASS, Baidu, and QZSS, and we are still waiting that the chips will integrate our IRNSS as well. But currently the smartphones receivers are capable of receiving signals from GPS, GLONASS, Baidu, QZSS, and also SBAS. So they are coming with that. So if anybody is trying to or going to buy a new smart mobile, and he is enthusiast or a user of a GNSS services, then he must look that what are the capabilities which that mobile will have, and if it supports the multi constellation, that would be very helpful, and of course it will provide very accurate positioning. What we are seeing here, that the different sectors we will go through one by one. So the first sector is the road, which is one of the major users of apart from this location based services which we have just discussed, and road navigation, that the personal navigation devices, that is P&D, which occupies the maximum market, and then you are having the in vehicle systems also inbuilt inside, and that is also there, and there are then digital tachograph and other users are there, but the major two users, the personal navigation device, that is P&D, and in vehicle systems IBS, which is nowadays coming in many of modern cars. So these two are basically for road navigation. So since 2008, the annual GNSS shipments worldwide have stabilized to 50 million units per year, thanks to success of navigation solutions, and especially in particular the portable navigation devices, because these devices were being used separately, but because of mobiles, this is the uses of this portable devices is also getting stabilized, and that is why you are seeing that in recent years the growth in this P&D has reduced, but at the same time in vehicle systems have taken place. So the growth in this IVS has increased, and overall growth of road navigation systems is almost remain same. So in the last few years, smartphones had a disrupted impact on P&D market, because smartphone not only for calling or sending SMS, but they are becoming basically multi-purpose devices for many purposes or things which one can do with that. That is why they are becoming popular, and that is why they are consuming the other possibilities or other market like P&D or IVS system and other things. And this all is happening because, as mentioned in the beginning of today's discussion, that improvement in the GNSS receivers and their performance, that is a assisted GNSS and multi-constellation. These two things have improved the location, and that is why the market is growing, and it will grow. It will grow because new applications will come. We might not be thinking today, but tomorrow some people, as per their requirements, will develop new applications, because some new applications which have not yet been developed because of accuracy issues. Once we reach the accuracy of centimeter accuracies in smartphones, GNSS receivers very easily without much efforts, then new applications will definitely be developed. So this said, we have seen that decrease in P&D portable navigation devices sale has reduced, but it has been compensated by IVS, so that annual average increase of about 11% in the road sector. Such growth is motivated basically by the commercial opportunity offered by IVS as a platform enabling navigation and connected vehicles, as well as many other GNSS enabled services which are meeting the user demands and comforts, infotainment and safety. So, lot of vehicles are coming with fitted with these IVS system, and they are not only providing navigation, but some other advantages as well. And one need not to then bother about charging and other things, because if you use mobile as a navigation in your car, then you have to think about that, how to fit it and so on. But in IVS system, it is all fitted and ready to use. So, whenever you turn on a vehicle and whenever you want to use the navigation facilities in your car, just switch on and it is available. So, there are number of additional applications, including road user charging, which is going to come very soon, already there in some countries, where the location, once you enter in a say expressway, your location is recorded. When you exit, about to exit from a expressway, your location is again recorded and the distance is calculated, and accordingly one has to pay. So, that is what road user charging RUC technology is coming in a big way. That will again increase the GNSS market, because then vehicles will require to have such devices inside their cars or vehicles. Insurance, telematics, that is also will utilize these things, and e-call is there, and accounted for, which will accounted for about 3 million additional units shipped in 2013. But this is little older data, and I am sure that this market, RUC market, is going to grow at a very fast rate, including in India. Also that GNSS based tolling, which we have just discussed, is being increasingly adopted. With GNSS based tolling, users can charge based on different criteria: the type of road, how much time they remain on the road, what are the distance they have traveled, what type of vehicle, because for different vehicles you have to have different rates. A small car owner will pay less, whereas a huge truck owner will pay more, and how much emissions it is putting in the atmosphere. So, all these things can come while tolling is there, and many of such things can be estimated or calculated about the usage by using GNSS devices. Indirectly, at least the distance and time, and that can be done quite easily with this. And the other benefits of GNSS in complex new networks, including low transaction cost, minimal environmental impact, and additional revenues from value added services, which is going to be there. Now, in this finally in this road navigation sector, the principle of GNSS basically is the positioning, and of course, with the performances of high influence by the conditions of operational environment and the need to ensure appropriate performance throughout the equipment's life. And the development of standards and certification references to positioning performance is fundamental for vehicle vendors and services providers, especially when it concerns safety critical applications. That means that when for tolling or for road uses will be there, then lot of standardization has to be done before it is implemented. And there will be other concern, especially related with the safety and critical applications, that in all conditions it should work, and not only work, it should work very accurately, so that in all conditions or all environment it should work. It should not that during rain or during winter it will not work, only in normal environmental conditions it will work. Then nobody will adopt and there will be problems. So, if any technology has to be adopted, it has to be standardized and the performance has to be checked before it is implemented. And finally, that automotive industry, which is related with the road, agrees on future view of a sensors fusion. So, the GNSS receivers will be a core component of that sensors fusion, which will be integrated into a car, provide enhanced positioning capabilities to be used with a plethora of innovative applications. So, all this is are either has already been implemented in some parts of the world or are going to be implemented very soon. Also, we know that when we look this road scenario, road navigation, one of the few applications which are extensively being used in large cities, that is for taxis, and they are extensively using 2-3 technologies together in an integrated manner. First of all, they are using your GNSS devices for location. Second, they are using the GIS, that is in the background, the map is always there, and including the database which is attached in the with the GIS platform. And third one is the communication technology. So, all three these technologies through a mobile and of course, a server and control centers are being used, so that like in case of road, when somebody would like to drive from one place to another or would like to hire a taxi like Ola or Uber or Grab in Malaysia, and so many other countries such services are available, very famous services, and which are relatively cheap than conventional taxi services, because they are maximum utilizing their resources, and rather than a taxi is traveling and say in a Delhi city without any passenger to pick a passenger or dropping a passenger. After that if they are traveling for just empty, then it is a loss of resources. But employing this GNSS, GIS and communication technologies, once they drop a passenger and within a few meters or maybe a 1 kilometer distance, again a passenger is available within a very small time, and that saves not only the time but the resources, and therefore these taxis services are becoming convenient and cheaper as compared to the conventional one. And there this technology has been used extensively in a completely integrated manner. So, these India's most popular Ola or Uber mobile apps are there for transportations, which integrates the city transportation, that means road maps and other things for customers and driver partners onto a mobile technology platform. So, of course, in the background there are servers which are handling the requirements of the users and giving support to the taxi operators, but main app or applications are being run on the mobiles, smart mobiles, quite easily, and these softwares have been designed so user friendly that anyone in just in 2 minutes time can learn how to call a taxi through these services and save time and resources. So, this is the India's fastest growing sector or companies, which as we have mentioned that it is creating or ensuring convenience and the quickness in the service. So, as soon as you call, within few minutes, if you are not in a very isolated place, you within few seconds you get a taxi available to you, which is, as I have already mentioned, using GNSS, GIS and communication technologies to make this whole system of transportation by taxi is hassle free for almost everyone. So, this is the real ultimate use of these technologies, which is currently. Future it is very difficult to predict, but anyway these things may become further efficient and further more friendly for users. The best the requirements for this is that they require not only accurate GNSS receivers in their smart mobiles, but also a very good street map of a city on a GIS platform. That is very much required, and then of course communication also, because your smart mobile is not having that kind of detailed map available through Google Map or others. So, they are maybe updating accordingly, and such services are available. They have to grow, they will be growing much more. So, instead of currently these services are available in large cities, in very soon they will be coming in medium size or even smaller cities, such services. So, GNSS is included in all modern aircraft. We know when we discuss the aviation, and all modern aircrafts are equipped with that. They are also having SBAS capable receivers. So, multi-constellation plus SBAS is also there, which is fitted as a standard for not only business but general aviation aircraft as well. And as you can see that this commercial aviation is one sector, but the maximum is this regional aviation. It is growing at a very fast rate, occupying a large market. Then you are having this general and business aviation, which is also having in orange color, and then you are having this in blue color, the search and rescue operations. So, they are also using GNSS in aviation sector. And in general, this aviation is the largest aviation sub-segment, which more aircraft and pilots than business, regional and commercial segments are combined. So, they are the general aviation is the largest user of the GNSS services. Now, the sales is basically dominated by visual flight rules. So, because not only for the pilots, but the passengers also, they would like to see where we are flying and at what speed, at what height. So, all that data is required, and this is due to cost of devices certified for instrument flight rules, that is IFR. Most commercial, regional and business aviation aircrafts are retrofitted with this enhanced avionics only once during the aircraft's lifetime. So, they are also new requirements are changing, new regulations are changing, because in this sector the paramount requirement is the safety, and whatever is required for safety, it has to be done, and that is why retrofitting of new systems, new requirements have been fulfilled there. Another sector which is growing in a big way which is part of aviation is this UAVs or these unmanned aerial vehicles are there, and which is again emerging and promising market for GNSS aviation. It is already has become a quite big market for many purposes, not only from a security point of view, but in rescue operations or for infotainment and many things. People are using these vehicles, unmanned aerial vehicles, and which requires a very precise positioning, so that these all sorties, if somebody is trying for a scientific application or maybe in agriculture or maybe in some other fields, the main requirement is precise positioning and of course the orientation. So, precise positioning can come nowadays through net, as we have discussed, or SBAS, maybe RTK or maybe DGNSS. So, these UAVs are also is a big opportunity in that sense, and wide range of civil applications will further drive market growth in aviation sector also. Now, rail sector is also, as you can see, that what is the growth is very significant in rail sector, not only in India, but in all over the world. As you can see that what was the scenario in 2013, and this is predicted for after 10 years, that is 2023, and this is how it is going to grow. So, in rail applications, like in India, Indian Railways is putting GNSS multi-constellation receivers on their all engines, so that plus their transmitter, so they can transmit the location to a central location, so that the control room would know where which engine or which train is going where, standing where, since how long, and so on and so forth. So, because of these such requirements, railway is also bringing all this. Sometimes there might be some limitations might be there because of visibility, maybe when it is going through forest or going through a tunnel. Those for those minutes that visibility problem will be there, but in most of the time it might not be there. There might be some problem about multipath, and even electromagnetic interferences are also there. But nonetheless, this is a big market which is growing. Now, GNSS performance compliance to expected requirements for safety relevant rail applications. Whenever it is employed in road, rail and aviation, especially in aviation and rail, and of course in the road, the safety is paramount. So, anything which is implemented in this, the safety have to be very much there. And as you can see that 220,000 trains in the world dedicated to freight, and these goods trains are wagons, and they are equipped with all these receivers. So, millions of receivers are there in these trains. Earlier, like in India, it was very difficult to locate. Now, because of this GNSS services plus communication, now we can track any train, at least any passenger train by civilian, or but railways can track any train, including goods train also. And this market is going to grow in coming years. Safety relevant applications will come, might be in signaling and train control based on the GNSS will increasingly develop. For example, like maybe autonomous trains for long distances. There is a possibility once this technology becomes accurate and reliable, then this is the future in the rail sector about GNSS. And despite this trend to include GNSS in safety relevant applications, GNSS is currently used in non-safety relevant ones such as passengers information and access management, where technology's innovation plays an important role. So, that they are also being used. And due to upcoming market opportunities in rail sector, the manufacturers are preparing to enter railway signaling domain, which belongs within the realm of safety relevant applications. So, because signaling is from safety related thing or operations of rail trains, so there also applications are being developed, so that one day we will have that services as well. Of course, the maritime for the sea or for the ships, this has been there, and this market is also growing, as you can see here, that large users are recreational and for the search and rescues, and there are different types of maritime uses of GNSS, which you can see mainly for positioning, because you do not have in cities or on land part, sometimes you are having references. So, in the beginning of this course, we discuss about this back bearing concept, but that is applicable mainly for the land part. In the sea part, when you do not have any landmarks, how you will locate. So, for that purpose, of course, GNSS devices have always been very useful, and they are being used. But for more accurate positioning, now these multi constellation GNSS devices, as you can see, for the recreational services, they are the largest users here. E-navigation initiatives of this International Maritime Organization IMO aims to enhance the safety and ease of navigation by integrating all navigation tools in all encompassing bridge system. So, as I have been mentioning throughout this course, that as accuracy will improve, as the efficiency and the availability of such devices becomes a real possibility, then more applications will come in all domains. As you know that the positioning requirements in maritime domain is widespread, and not only for different types of vessels. Earlier we used to have beacons or these towers, lighthouses for navigation, but no more required. So, like in aviation sector, most of the modern aircrafts are fitted like in car sector, most of new cars are fitted with navigation systems. Similarly, all these ships or small recreational vehicle, ships or boats are also fitted with these navigation devices, so that they can utilize, and the life becomes much easier for locating in a water body. And of course, the performance requirements will be there for GNSS solution, basically, which will depend on the applications, how they are being applied, and there will be other issues also related with improved safety and productivity. Accuracy is key part, and integrity of this service or these devices will be there, and which is a key for navigating restricted waters as well as for positioning applications. This is very important for restricted waters, because each country is having their own boundaries within the sea part or in the water bodies, and because you do not have the landmarks, so sometimes these boats which are going for fishing, they might cross to other countries, and it happens many times. We hear, like in India, it happens between India and Pakistan, and then they catch each others, instead of catching fishes they catch the humans, and these are just because of poor navigation and devices or systems which they are having. But in future, I am sure with some alarming techniques inbuilt in their systems, and they will never cross restricted waters. So in that way, lot of problems can be solved. Not only problems, but maybe lives can be also saved, because of sometimes crossing each other's water creates confusion and some other disputes as well. So those disputes can be in future, hopefully will be avoided with the better navigation systems fitted in those boats or ships. As you know that around 29 million recreational vessels are in use. That is why the maximum users of GNSS in maritime is in recreational is used, and whereas other crafts, fishing vessels are estimated to be about 3.3 million. And this explains the relevance of GNSS shipments for recreational navigation, and despite the fact that GNSS is penetrating is high in the merchant vessels than in recreational or fishing vessels. So this is again a big market, like in the road, also in the maritime. And apart from this recreational navigation, search and rescue, that is also a very big sector, not only in maritime but also on the road as well as in the air also, and the reliability is very much required. Search and rescue services based on GNSS or other technologies is also very much required in case of natural disasters like in earthquakes, flooding and other things. So lot of these are becoming use of this one. In coming years, recreational vessels will be responsible for further growth of GNSS yearly shipments, because this sector is growing at a very fast rate, and these GNSS shipments for merchant navigation are expected to almost double in next 10 years, including some 50,000 units. So big development there. Now we also very briefly we will touch about the agriculture sector, application of GNSS in agriculture sector. As you are seeing, there is also a quite steady growth in this sector, and nice future is predicted in agriculture sector. But in agriculture, as I have already mentioned, in those countries it is possible where they are having large farms. But countries like in India, we do not have much large farms, and the individual farmer cannot really afford for such kind of harvesters or putting fertilizers or seeding in agriculture sector. But nonetheless, there is a growth, and that will penetrate once these becomes much more cheaper. So even a small farmer holding a very small land can may imply in future about this, along with some other technologies like UAVs and GNSS for putting fertilizers or seeds or whatever, harvesting or assessing the production. So, increased efficiency in GNSS will allow farmers to have their own address challenges of water shortage and soil fertility. So, that as it becomes efficient, that includes accuracy as well as easiness. Once this becomes very easy, this technology, it has already become, but only for mobiles, but for other equipments may not be as that good. So, once it becomes as reliable and easy, definitely more uses will come in agriculture sector also. And like for example, in during 2006-12, global shipments of the installed base of GNSS devices in agriculture segment have more than tripled. So, it is growing at a very fast rate. Integration of GNSS with the farm management information system together with the use of additional information coming from various sensors has revolutionized the precise farming. So, this precision farming is what is current trend in agriculture sector. It will become much more as more efficient GNSS devices are available and are integrated with other equipments as well. Like in for example, in North America, which is accounting 57% of all GNSS devices, because we know that they are having large farms and of few acres, a single farm of few hundred acres, and therefore it is possible to employ all this. In Asia Pacific region, which includes India, which is made of countries with very different agricultural features, especially small farms relatively, but still this market of GNSS devices is growing about which was 17% in 2013. Additional sensors can be used to enable remote sensing with additional information being provided by earth observation systems and meteorological stations. Especially farmers are interested to know about the moisture condition of the soil. Not only the soil, but also moisture conditions, and that can come through the remote sensing technologies. And of course, the location has to be there so that the a selective treatment can be provided. There are more affordable dual frequency. We have been mentioning about dual frequency GNSS multi-constellation also receivers which will emerge with precise positioning solutions, will further support precision farming, contributing for example of improvement in GNSS based machine auto guidance. So, automation in agriculture sector based on the GNSS and other technologies is a future in that. Now, we also briefly will see the surveying sector. It is already there extensively civil engineers for topographic survey or other surveys, they are using these differential GNSS or RTK services for surveying, mapping and construction machine control, that is machines, large machines for in the construction industries are also employing GNSS. This sector is also having good future, that we will be having like computer aided designs. So, we will be having computer aided constructions also might be in future. And these the install base of these devices has tripled over past 8 years from 140,000 units in 2006 to 426 units in 2013. And in Asia Pacific also the growth is quite significant from 11% during the same time period to 30%. And this surveying cadastral surveys, like in this country most of these khasra maps which are called in North India, in other states they call as other, but as we know we call as a revenue records or cadastral maps. And these cadastral maps were in analog form without any geographic location, that means latitude, longitude or other information, or without any database basically. These maps had just numbers. So, now they are being digitized and they are being brought into the GIS platform, and of course, then these are being attached with the coordinate. So then in this sector also there is a utilization. Many states have already digitized their land records or cadastral maps, and this fully they are utilizing for the fair principles of fair taxation, and maybe for other like in agriculture they would like to assess that before a crop comes in the market, that how much wheat has been sown in a particular area or in a state, to estimate the crop production, so that accordingly the country can think about storage and prices and other things. So that all coming also through this technologies, including GIS and remote sensing as well. As we have been mentioning that construction activities also played a significant role in fueling growth, largely due to the construction boom in emerging markets and post-crisis recovery in established ones also. And in Southeastern Asia, the growth is 7.5 compared to 4.5 in United States and 4 in the, so developed countries are having less growth, as you know that more infrastructure and other housing is required in developing countries, and therefore the growth is much more, and accordingly the applications of GNSS are there. As when we saw the overall utilization of GNSS or the market share, we saw a very small market was for, or users are currently on timing and synchronization, but this is the sector which is also will grow, that is precise timing and synchronization is crucial to range of strategic activities, and not only in the aviation sector, maybe in train or others, but there are many other sectors where we require a very accurate timing. So in that synchronization is also possible, apart from that frequency calibrations and other things. So because satellite communications, these signals are available all the time, so our clocks can be made very accurate, can be synchronized through this, and cellular networks can also utilize this synchronization of time slots and for handovers between base stations. So that is also possible. There are some other technologies are coming, which is public switched telephone networks, which requires again a very accurate timing. So GNSS can provide timing as accurate as atomic clocks. So this is a one sector which is there, though it does not occupy a large market, but there. In the financial services and in share markets, every second counts there, and one country, someone like Japan starts first and then it goes to US, and there the time is very important. So there also it is playing a very important role, the synchronization for time stamping functions to log events and codes for chronological manner. So there also, one of the professors that David Last, who is a consultant engineer and expert witness specializing radio navigation and communication systems, he mentioned that the advantages in the countries or regions of providing their own GNSS are political, not technical. But this is what it is thought, but users are going more technical in that sense. And indeed so many satellites are now transmitting, that means so many constellations are there in the same narrow radio bands, that are additional ones are raising the noise levels which they all have to cope, because the part of electromagnetic band or wave band which is available for communications through these GNSS constellations is very limited. So there is of course concern about the noise level which may create some problems, but like if Galileo is using certain bands, so those signals, because being currently regional system, so we do not get these signals over India, so there is no interference with the, even if they are using the same wave band. So, if countries are having their own regional systems, then this issue of noise level or encroaching each other's will not come and may not become big, but anyway this is a concern. And many recent incidents and surveys have shown that the threats of interference, jamming and spoofing are real and serious. So, spoofing, and this is a problem, but as you know that whenever a new technology comes, some hazards also come, some people creates problems, and that will be of course all the time will be there. So, this brings to the end of this discussion, and this has been little longer, but from opportunities and future trends point of view, it was very much required and to complete or comprehend all aspects starting from road to time synchronization. And as usual, I am again leaving with a new cartoon just to enjoy and smile. Thank you very much.